Okay, welcome to WSQ Similar Polygons. This will be a continuation of what we've done in class today. It will be, I think, a pretty short video. Again, just kind of expanding on a few things. Okay, so the biggest difference now in what we did in class earlier is now you'll notice we have a variable, z. We're trying to solve for a missing side. Okay, so I'm going to tell you the best way to do this is to figure out what the scale factor is. So in class we said the scale factor was going to be the ratio of corresponding sides, and that's going to be reduced down. So for example, JK corresponds with the side here, QP, which we don't know. JM corresponds with PS. ML corresponds with RS. Notice KL corresponds with QR, and we have numbers for both those. So I'm going to go ahead and put KL over QR as a fraction or as a ratio, so 15 over 6. And I'm going to go ahead and reduce that to the lowest possible terms just because it's a pretty good idea to make sure our scale factors are always reduced. Okay, so that reduces down to 5/2. Okay, so now basically if we want to solve for any variable, we're going to set up any corresponding sides equal to 5/2. So let's go ahead and find the value of z. So I'm going to set up side JK here, which is 10 over its corresponding side, QP, which is z. And I'm going to set that up equal to 5/2. Now we can go ahead and cross multiply. 10 times 2 is 20. 5 and z, 5z. So z should have a value of 4. Okay, so let's try another example. Notice with this problem now, there are two variables. So I would say the same thing. There's multiple ways you can do it, but I like to go ahead and just find the scale factor right away. Okay, that way I know I'm going to set it up equal to that scale factor every time. So we know that they're similar. It tells us right in the beginning of this problem these two polygons are similar. So we notice we have a number here for SR. That's 32. Okay, I'm going to go ahead and put that over its corresponding side, MN here, which is 16, which we'll notice just reduces down to 2/1. Okay, now what I can do is I can go through this problem and set up our ratios of corresponding sides equal to 2/1. So let's go ahead and find x, and I'm going to use a different color here. So let's use this blue color here. That's not blue. Well, that's not working, so that's okay. We'll use black and pretend it's blue. So let's write x over the corresponding side, which is 13, and set that up equal to our scale factor, which is 2/1. So it is really important to notice that x and 2 are both on top, and they are both sides on this triangle. Okay, 13 and 1 come with this triangle here, so they correspond with that smaller one. Okay, so that's definitely an important part. So let's go ahead and cross multiply. 13 times 2 is 26. Okay, and x times 1 is obviously just 1x, so x would have a value of 26. Okay, let's go and try another one. Okay, and let's go ahead and use, now it wants to be blue, RT. So let's go ahead and use 38. Put that over its corresponding side, which is y, which is here. Okay, and again, we can set it back up to that original scale factor we just found as 2/1. And you can see once we have that scale factor down, it makes it a little easier. 2 times y is 2y. 1 times 38 is 38. We're going to go ahead and divide both sides by 2. Y equals 19. Okay, and there are other ways to do this. Okay, this is just one of many. But again, I recommend finding that scale factor, and that's going to stay consistent again throughout that entire problem. Okay, so we're going to go ahead and try an example problem, and this is one where I'm going to have you pause it and start it up again once you see if you've gotten the right answer. Now it says on here find the value of x and y. Let's see if you can throw w in there as well. Notice there's three variables now, w, x, y, and z. So see if you can find that. Again, find the value of the scale factor first to set those ratios all up equal, and see if you can find those variables. Go ahead and pause the video now. Okay, let's see how you did on these. Again, hopefully you found the scale factor, and I'm going to use The scale factor for now, just a small abbreviation, is a lowercase letter k. We're going to set up our ratio of some sides we noticed that have some numbers there, and the only ones we could use are 15 and 12. Notice if we tried to put 25 over w, doesn't work. Y over 16 doesn't work. X over 10 doesn't work. There's all variables on those other sides. So the only one that has numbers for both of them, 15 and 12, reduces down to 5 over 4. Okay, so that is our magic number. So we're going to set all of our corresponding sides up equal to that ratio and help us to solve. So let's find the value of, doesn't matter, let's do w first. So here's the side that corresponds with w. We're going to do 25 over w equals 5/4. Okay, let's go and set up another problem. So let's do this one. Let's do x. So x over 10 equals 5 over 4. Notice these numbers are just staying the same, the ratio for the scale factor. And then our last one, let's do y. So jm over ps, which is y over 16, equals 5/4. Okay, and for all of them, there's the easy part. We just cross multiply and divide. Okay, so first one, 25 times 4 is 100. 5w is equal to 100. W equals 20. Okay, there's a value for w. Let's do the next one. 4 times x is 4. X. 5 and 10 is 50. We divide, we get a decimal. X is 12.5. Okay, and the last one. 4 and y is 4y. Okay. 5 and 16 is 80. Divide both sides by 4. Y should be 20. Okay, so there's our, again, value for all three of those variables just using one scale factor. If you are in regular geometry, you can go ahead and stop right there and start your WSQ. If you're advanced, I have one more type of problem we're going to do so you can continue on to the next problem. Okay, so for advanced geometry, we're going to take a look at perimeter with triangles, and again, perimeter just meaning the sum of all three sides. Okay, we could do this for quadrilaterals as well, but just to show you the relationship between similarity and perimeter of a figure. So what we want to do first is to find the scale factor. Okay, so notice we have 8 corresponding to a side of 12. Let's go and write that down as our scale factor. Oops, let me get my pen back here. So 8 over 12, okay, which reduces down to 2/3. Now our next step, we want to find the perimeter of triangle DEF. And again, perimeter is just going to be 10, 8, and 12. We add those together, our perimeter is equal to 30. Okay. Now we want to find the perimeter of HGJ. Okay. We already know that what the perimeter of this one is. That one's easy. So it says find the perimeter of each triangle. Okay. So let's go ahead and do that. Well, what we're going to do is we're going to take our scale factor, which is 2/3, set that up equal to 30, which is the perimeter of DEF, over x. Okay. So the perimeter is actually going to be proportional as well. So once we go ahead and cross multiply, 2x equals 90, and divide, the perimeter of that other triangle is 45. Okay. So last one, okay, and then we'll be done for the night. Go ahead and try an example, a little different. Okay, perimeter of PQR is 70, PQ is 21, and PQR is similar to STU. ST is equal to 15. We want to know the perimeter of triangle STU. So it's probably a good idea, go ahead and pause it, see if you can do this one on your own, and then start it back up to see how you did. Okay, let's go ahead and try this out. Okay, and you can draw a picture if you want, but you do have a similarity statement here that helps you out tremendously. So we know the perimeter of PQR 70. Okay, we do not know the perimeter of STU. So that's what we're solving for. So again, basically in my proportion, I got PQR on top, STU at the bottom. These two numbers correspond to the perimeter. Perimeter of PQR, perimeter is unknown of STU here. Okay, so let's go ahead and set up our other side of our proportion. We do know that PQ and ST correspond. And how do we know that? Because of our similarity statement. PQ, ST, they're corresponding sides. So we can write that out as 21 over 15. Okay, if you want to reduce that down to your scale factor, okay, you definitely can. It doesn't really matter. It's just kind of a preferential thing. I'm going to go ahead and do it, so I'm just going to erase this 21 over 15, okay, and I'm going to reduce it down just because I like it in the lowest possible terms, okay, to 7 over 5. Okay, and again, that was 21 over 15, just reduced to 7/5. Okay, cross multiply and divide. 7x, okay, is equal to 350. Divide both sides by 7. There's our perimeter, okay, of that other triangle. Okay, and it's done. Okay, so you can go ahead and stop the video now. Make sure you complete your WSQ discussion post, and have a great night, and I will see you tomorrow.